So we were talking about this problem, okay? One of you was asking why we considered that h is the height. So here, if you want, in the figure, it is little bit not very clear, but you can consider that this small part is negligible, okay? So this is why you can consider that the height in the cone is equal to ht. So now, if you want to write the expression for the volume in your cone, you can say that this volume is equal to the height, for which we consider that the height of the cone is equal to h, okay? And because if you take these lines like this, nearly, okay, you can consider that the height is given by h of t. Here in the figure is not very clear. You can see a small difference, but it should be clearer. And they should put h from here, okay? So this is the level of water inside the cone. It's equal to h, and here the base of the cone is equal to h tangent theta, because from geometry in this triangle, if this is h and this angle is theta, then the base radius is h tangent theta, okay?
دكتور هو الثeta بين وين وين بس؟
الثeta بين الvertical والcone edge. You have here, this is the cone edge, and this is the vertical height. Theta is the angle between them here. Okay, so in this triangle, it's a right triangle of base. The base of this triangle is the radius of the cone base, and the height of this vertical height represents the height in the cone. So in this right triangle, from geometrical relation, you can say that the radius of the base over the height of the cone is equal to tangent theta. This is why the radius of the base will be equal to h times tangent theta. Okay? So now, if you replace in your equation, you have d by dt. We said that integral rho dv can be replaced by rho times v, times the total volume in the cone. Okay? But now, if you want, you will replace v, we will replace v by its expression. And you know that for a cone, the expression for the volume is pi over 3 times the radius of the base square times the height. Okay, so this expression, this represents the volume of the cone. This is v. Okay, so this is volume of water. This is the volume of water inside the cone minus m dot n, and m dot n we have already developed the expression before. It is equal to rho times pi over 4d squared times kt. Now here for this term you have several.
دكتور هي pi over 3 r squared times h صح؟
مظبوط. Okay. Now for this term you can take outside of the integration rho and pi over 3 and tangent square theta square. You will only have inside the integration what? You will only have h cube inside the integration. Okay. So you can write now that you can replace your term. Look, what we will do together, we will do separation of variables. Okay, so you have a constant that you can take outside, rho times pi over 3 times tangent theta square. You can take it outside of the integration. Okay, and what you still have inside, you still have d of h cube. D of h cube. Okay, and I will take dt to the other side to do separation of variables. So taking dt to the other side, you have equals to pi over rho times pi over 4 times small d square times k dt. Okay, so now if you integrate from both sides, you will integrate here يعني for the first side you integrate this one, we integrate this term, integrate between what and what, from 0 to h, okay? While for this term here, okay, we will integrate between 0 and integrate between 0 and t, okay? And if you want here dh cube, so your function here is your elementary function is h cube, so you integrate between 0 and h cube, okay? So you get the value that you have. You get that rho pi over 3 h cube tangent square theta is equal to rho times pi over 8 d square k t square, because here you have kt, okay? We should add t. Integral of t is t square over 2. Integral of 1 dh cube is h cube, okay? So all you have to do now is to rearrange your terms so you can get h function of time.
Doctor,
Yes.
maybe repeat just the last part of the integral.
Yes, of course. Look, I will do it in more details if you want. If you have dh cube, you can do two things. Or you integrate between 0 and h cube, okay? So it's like you have integral of 1 dh cube. It will give you what? So you have, this is a constant. It is outside, okay? If I give you any function, I tell you integral of 1 dh cube. What is the integration of 1 dh cube? In calculus, how you do this integration? What is the integral of this function? When you have 1, so your integral is the function itself. What is the function itself? H cube. So integral of 1 dh cube is h cube. Okay. Now, if you are not familiar with this method, you can replace h cube by what? By 3h squared dh. And dh cube is equal to 3h squared times dh. In this way, you have transformed your integration from function h cubed to function h. In this case, you integrate between what and what? You integrate between 0 and h in this case, okay? Between 0 and h, okay?
نحن بالاول وقت we integrated مش ظهرنا رو لبرا وقلنا ان انتجرال لدي في هي the total volume.
مظبوط.
اوكي and then
اوكي
هون
هلا
ليه صار في
فيك تطلع رولا برا. مظبوط، فيك تطلع رولا برا دي في. انتجرال دي في شو بتعطيك؟ the total volume of water
the
inside
total volume.
صح؟
مظبوط. بقى عندنا دي اتش كيوب بدنا نعمل لها انتجرال. اوكي
صحيح مظبوط. هيدا الفوليوم we just replaced by the volume. هلا وقت وصلت لهي الاكسبريشن عندك function، عندك two variables h and t, so you do separation of variables. Okay, once you do separation of variables, you get for your first term you have rho pi over 3 tangent square. You should integrate 3h squared dh, or you should integrate dh cube. It's the same result whatever you do. Okay, and from the other side you should integrate this constant times t. So when you integrate with respect to time, you have the constant times t square over 2. So you get the constant over 2 times t square. So it is rho pi over 8 d square k t square. Okay, any problem on the method? Do you want me to do more details on this, or it's fine? So after you integrate with your boundaries, and look, they gave you that for h equals 0, t equals 0. So when you integrate for h, you integrate between 0 and h, and for t, you integrate between 0 and t, and you end up with the following relation. Okay, now to find h as function of time, here you have h cubed. So you take the constant to the other side, and you do the whole term to the power 1 over 3. Okay, so if no other questions, let me start a new problem. Okay. In elementary compressible flow theory, compressed air will exhaust from a small hole in a tank at the mass flow rate m dot equals to c times rho, where rho is the air density in the tank and c is a constant. If rho 0 is the initial density in the tank of volume V, derive a formula for the density change rho T after the hole is open. Apply your formula to the following case. A spherical tank of diameter 50 centimeter with initial pressure of 300 kilopascal and temperature of 100 degrees, and a hole whose initial exhaust rate is 0.01 kilogram per second. Find the time required for the tank density to drop by 50%. Okay, so let us solve step by step this problem. First, you have an incompressible flow. A compressible flow. When you have a compressible flow, this means that the density rho can change. Okay, and here they gave us m dot function of rho. So m dot that is flowing out from the hole is a certain constant times rho. So higher the density in your tank, higher will be the exiting mass flow rate. Okay, now we want to derive a formula for the change in density rho function of t, knowing that the following conditions are given. Okay, so they gave us the geometry of our system. We have the spherical tank of diameter 50 centimeter. They gave us the initial pressure inside the tank and its temperature, and we will see why they gave us the pressure and the temperature to find what. This
Can
information,
you repeat the question?
yes, why they gave us the initial pressure and temperature, P and T. It is, you can treat it as an ideal gas here. Okay, if you have an ideal gas, if they give you the pressure and temperature, you can calculate what?
نجيب رو.
نجيب rho, صح. So we can find the initial rho by giving us pressure and temperature. Okay, now let us try to write the equation for this problem. First, they want us to find what is the time needed to have the density dropping by 50%. So we need to find rho function of time. Okay, to do this, whenever you want to relate density to time, you should think about the continuity equation. And here it's a non-steady equation because it's function of t. So I will start first by writing the continuity equation. Okay, the continuity equation states that, as we have seen in the previous problem, d by dt of integral rho dv plus m dot out, and in general we have also minus m dot in. But here they didn't include the term. Why? Because you don't have an inlet, you only have an outlet. So in general we have minus m dot in. Okay, but this term here is 0 because we have only an outlet, we don't have an inlet. Okay, now let us replace the other terms by their values. Okay, first, if I considered m dot out is given in the problem because they gave us that m dot out is function of the density. M dot out is equal to a constant, a certain constant, times the density of air inside my tank. Okay, so I still only need to evaluate this term, d by dt integral rho dv. Okay, now when I say integral rho dv, now I have in this case rho is not a constant. Okay, but rho is only varying with what? Rho is varying only with time.
With time.
Yes, not with space. What this means, so for a certain time the density is the same everywhere in my volume. Okay, so now if I consider my volume and I take several points, all points at the same time t will have the same value of density rho. So this is why when I integrate with respect to volume, I consider that rho is a constant because it's not varying with space, it's only varying with time. So I can take v out. Okay, and also I can say, like the previous problem, integral rho dv can be replaced by rho times the volume of my air, which is inside. Okay, now Since my tank is of constant volume, because I have it is characterized by a certain radius which is not varying. It's a solid tank. Okay, so I can take V outside of the derivative, because now I am deriving with respect to time rho times V, but V is constant. I take it outside of the derivative, so I get V times d rho by dt. Okay, so my volume, the volume of my tank times d rho by dt is equal to minus m dot out. So as you can see here, you obtained a relation where you have two variables, rho and t. So the next step is to do separation of variables. So I will take c rho to this side, and I will
بس
take
دكتور ليش minus CP؟
مش cp, c rho minus c times rho. Okay, لأنه what is m dot out? Look, m dot out is given as a function of rho here. M dot out is equal to c times rho. And from the continuity relation here, you can say that derivative, so let me write it here. You have derivative of rho volume over time is equal to minus m dot out. Okay, so now since we said V is constant with space, sorry, the density is constant with space, so it's only varying with time. I can say here that my volume is independent of time, so I can take it outside. So I have V is equal to the derivative of rho. Only rho is varying with time. The volume is constant, so it's d rho by dt equals to m dot out is given in the formula by c rho, so it's minus c rho. Okay,
Here, why did we say that the whole equation is equal to 0?
because this is continuity equation. Before I take it to the second side. Okay, if you go back to the course material, when you say a system, the mass of a system is always constant. Okay, so derive
okay,
the
cool.
mass of a system with respect to time. What do you get?
0.
Yes, this is why the first term is 0. So if you go back to the Reynolds transfer theorem, dm by dt for the system is 0. It is equal to the other side to derivative of mass of control volume with respect to time plus m dot out minus m dot in. So always pay attention. For a system, the mass is constant, but for a control volume, it can be variable. Okay, this is why here the first term is always 0, because it represents the derivative of the system mass with respect to time. Okay, so you can understand more this if you go back to the material and you replace in the equation of Reynolds transfer theorem. So now this is your equation. You got v d rho by dt equals to minus 0. In this equation you have two variables, so you will do separation of variables, which are time and rho. Okay, so if I take rho to the other side, I get d rho over rho equals to, from the other side I have minus c over volume times dt. Okay, and now all I have to do is to integrate both sides. Okay, so I will integrate the first side between rho 0 and rho, and the second side between 0 and t. Okay, now for the second term it's very simple for me. I don't have any problem. I just need to find rho 0. Okay, and this is why they gave you the initial pressure and temperature, because if you know the initial pressure and temperature, and for air you have the constant R is known, it's constant equal to 287. Okay, so you can just apply that rho times P equals to rho RT. Okay, so you can say that at the initial state P0 is equal to rho 0 times R times T0, of course. Okay, so now if you apply, you can get the expression of rho 0. So rho 0 is equal to P0 over RT0 over RT0. Okay, and once we have the value of rho 0, we can perform the integration. And as you can see, the integration of the first term will give you ln of rho, and the integration of the second term will give you t. So you can find that rho over rho 0 is equal to exponential minus c over v times t. Okay? Now, we still have to find the constant c. C is not given. How to find it? There is one information that we didn't use yet, which is what? That the initial exhaust rate is given. The initial m dot out is given. So you can say that m dot 0, m dot at time 0, okay, is equal to, if you replace here in your equation, in your m dot equals 0, it's equal to the value of the constant times rho 0. So once you find rho 0, you can find the constant c, okay, because this is equal to 0.01. So the constant c is equal to 0.01 over rho 0. Okay, and now once you find rho 0, you can replace into your equation and find your constant c. And then the question was, find the time required for the density to drop by 50%. Okay, if we have it drop by 50%, so what does this mean? We can say that rho over rho 0 is equal to what? Is equal to 0.5. Okay, so you replace rho over rho 0 by 0.5, then you will get your only unknown, which is the time t. Okay, so let us see here what they did. So as we said, first they found rho 0 from p over rt, then they replaced into m dot 0 equals c rho 0 to find c, and of course for the tank volume they gave us the diameter, so the volume is pi over 6d cubed, and now we have all our constants. So we replace into the equation rho over rho 0 by 0.5. The only unknown will be the time t we get. Okay. Another problem. So now, until now, we have solved the problems on the continuity equation. Okay. Now we will start to do problems on force balance equation. So we have here a wedge splits a sheet of 20 degrees water as shown in the figure. Both wedge and the sheet are very long into the paper. If the force required to hold the wedge at rest is equal to 124 Newton per meter of depth into the paper, what is the angle theta of the wedge? Okay, so here in this problem, they ask us what should be the angle theta in order to keep the system in equilibrium. Okay, so whenever they ask about equilibrium condition, whenever they say this piece should remain at rest, then you should think about applying the force balance equation. Okay, which correspond to what? Which correspond to the second application of the Reynolds transport theorem, when you replace B by V, by the velocity V. Okay, in this case, what do you obtain? The equation you obtain is that sum of forces, okay, and here you can apply it in different directions, in X and Y, etc. But here, as you can see, our interest will be in F, because F is in the force applied is in the horizontal direction. So we can write from the Reynolds transport theorem applied on the velocity, we can write that sum of X is equal to m dot just 1 second. Okay, it's equal to m dot out plus minus m dot in un. And what do we mean by this? And of course, if you have several inlets, you do summation. Let us understand here how to apply this. As you can see in this figure, you have a force acting on this small piece, and you have also a flow that is flowing over the geometrical piece. Okay, so here I should decide about a certain control volume. My control volume should include will include the flow and the geometrical piece. Okay. Now, for this control volume that I considered, the inlet flow will be this one. So here I have an inlet flow, and from these two sides I have outlet flows. Okay, and I want to find what should be the angle theta in order for my system to remain at rest. What does this mean? If my system is at rest, the acceleration is 0. When the acceleration of a system is 0, then the Reynolds transport theorem, which is applied on it, will be simplified to sum of x equal m dot out u out minus m dot in u. Okay, so here let us apply this formula for the following problem. Do I have any other force acting in x direction other than the force F, this one? Look, your only force acting in x is this one. You don't have any other force. This is why when you write sum of x, you have first it's minus F equals to. From the other side, I will consider all inlets and outlets. Okay, let us start by the outlet. First, here you have two outlets. Okay, but it is clear from the figure that the two outlets are symmetrical. Because they are symmetrical, okay, then we can say that they are equal to each other. So m dot n is divided into two parts. This is the first one and this is the second one. So we can say that m dot out, okay, is equal to m dot n over 2. So how we can get this result? From continuity. So let us start by continuity. From continuity equation, here you have a steady application. When you have a steady application, you can say that m dot n is equal to sum of m dot out, because here you have two outlets. Okay, so you can say here that it is equal to 2 times m dot out. Okay, we assume that they are equal due to the symmetry in the figure. So here you have that to calculate m dot n. How you can calculate m dot n? You have the inlet velocity and you have the inlet diameter. Okay, so you can say that V inlet, so V inlet times area inlet, which is equal to 6 times pi d squared. D is here 4 centimeters, so times 0.04 square over 4 is equal to 2 times m dot out. Okay, so you can find the value of m dot out. Now, going back to the force balance relation, we have minus F equals to. Now, if you want here also, as you can see in your figure, the two outlet flows are, since they are symmetrical, they are doing the same angle with the horizontal. Okay, so this angle is theta over 2, and this one is also theta over 2. Okay, so I have here theta over 2, and the same for this one. So now, since I am applying my relation in x direction, so for both outlet flux, I should project the velocity along x. If I want to project the velocity along x, what should I multiply by?
Cosine theta.
Cosine theta over 2, not cosine theta. Okay, cosine theta over 2. So I will get that minus F, and since for both I should do times cosine theta over 2. Okay, so I will do F equals 2 times m dot out. Okay, m dot out times the velocity, the outlet velocity is 6 meters per second. Okay, so times 6
دكتور
times
2 times m dot out مش هي ده بدل
هي m
m
dot
dot
n.
n.
هي m dot
ايه
n.
بس
yes sure.
بس يعني مش لازم بدل محل m dot n.
لا، ما أنا هلا عم بعمل أول term. I'm working with this term. Okay, m dot out u out. Okay, هلا here I have two outlet. هلا هن لازم to be more accurate لازم يحطوا هون
حتى summation هيك.
yes لازم يحطوا summation لأنه في اثنين، بس هن اعتبروا إنه ال m dot out اعتبروها هي summation of both. Okay, يعني you can do whatever you want here because of symmetry. It's divided into two equal parts. So here 2 times m dot out هي equal to m dot n. يعني this term 2 times m dot out is simply m dot n. Okay. Now times 6, which is the velocity, and why we should project it, because we want u out, the component of outlet velocity along x. To have the component along x, we should do 6 times cosine theta over 2. So I should multiply by cosine of angle theta over 2. Okay. Now minus m dot n un. So it's minus m dot n, and u inlet is equal to what? To 6. Okay, you don't have to do any projection because already the inlet velocity is along x and positive x. So minus m dot n times 6. Okay, so now your only unknown in this equation is theta. All you have to do is to replace your force F by 124, and you already calculated m dot n, so you can get your angle theta, which will be equal to 48 degrees. Any
دكتور بس
question?
كيف جبنا ال m dot n الاريا هي 0.04 times 1.
لا here look, it depends if you what is the type of geometry. If it's a circular geometry, it's pi d square over 4. Let us read well the given to see. So here it's not a circular, it is like you have a certain width, okay, per meter of depth. So here I consider that you have a depth of 1 meter. Okay, since you have a depth of 1 meter, so your area will be 4 times 1. Okay,
بس كيف عرفنا depth 1 meter؟
ما هن قالوا لك if the force needed F is per meter of depth. يعني the F given is per meter of depth. So if you take F equal to 124 Newton, you take a depth equal to 1 meter. Okay, يعني هي كل ما زادت الدبس كل ما حتصير تزيد ال F، بس لأنه حطوك الفورس per depth per meter of depth، يعني you are doing the analysis for 1 meter. اوكي، يعني انت اذا بتاخد 2 متر شو بتصير الاف؟ بتصير 248. اوكي، so whatever is your force is proportional to the width. كل ما زادت الويدث كل ما زادت الفورس in the same amount, the same proportion. This is why theta will remain the same. اوكي،
طب هني هون بالسوليوشن شو عاملين؟
هن اخدين 1 متر، وقت ياخدوا 1 متر بياخدوا الفورس 124. اوكي
هنا اخذ 124 times 1
and then equals to
MN.
the other, from the other side you have m dot out u out minus m dot n u n. إذا أنت أخذت 1 meter for this term, okay, then بالاريا تبعك شو بتاخذ الاريا هون تبع الانلت؟ بتاخذ 0.04 times 1. okay، وإذا أنت أخذ 2 meters، يعني let's say أنت قررت تاخذ 2 meters، مع انه ما لها لزوم، يعني فيك تشتغل ب 1 متر اتس ايزير. اذا انت اخذت 2 مترز، اول شيء بدك تضرب هون الفورس اف بتصير 248، لانه بتصير بدك تعمل 124 تايمز 2، والاريا الرو اي في تبع ام دوت انلت بدها تصير رو تايمز الاريا بتصير 0.04 تايمز 2 تايمز 6. يعني انت كانه عملت تايمز 2 from the two sides, it will be simplified. This is why
بس دكتور هن بالايكويشن ما حطوا الام دوت اوت مثل ما كاتبينها بالبلو تحت.
بلا ما هن شو
وين
عملوا؟
الام دوت اوت؟
بتقول لك شو عملوا، اخذوها انتو فاكتور دغري اخذوها انتو فاكتور. يعني انت اذا بترجع للايكويشن تبعنا خد ام دوت ان انتو فاكتور، شو بيطلع لك؟ if you take m dot
يعني
n
جبت ام دوت ان وبعملها اوفر 2 لانه ام دوت
إيه.
ام دوت ان equal 2 times ام دوت اوت.
مظبوط، بس ما انت عم ترجع تعمل 2 times m dot out صح؟ times 6 times cosine theta over 2 لانه you are projecting the two outlet flows. فوقتها تيجي تاخد 2 times m dot out، شو فيك تحط مطرح 2 times m dot out؟ فيك تحط محلها m dot n صح؟ ساعتها اذا بتاخد into factor شو فيك تاخد into factor؟ فيك تاخد كمان 6 into factor، شو بيبقى جوا؟ يبقى cosine
3 اوفر 2 minus
3
1.
over 2 minus 1. يعني هن عملوها دغري in one step بلا ما يقسموها. Okay. So this is the same expression we got m dot n times the velocity times cosine theta over 2 minus 1.
دكتور ليه ما حطوا الماينس اللي بالاول؟
هن مغلطين لازم يحطوا الماينس. اوكي يعني هون
اوكي
اذا بدكم ناسيينها هن فيهم يحطوها هون ماينس. اوكي اصلا ما شوفوا اجباري تكون ماينس لانه كوساين هيدا نمبر اصغر من 1، يعني هيدا نيجاتيف، هيدا الترم نيجاتيف، فاجباري يكون في ماينس 1. اوكي any other question on this problem؟ حدا ما فهم الايديا of الويدث؟ يعني انتم بس يعطوكم per meter of depth اشتغلوا for the width equal 1 meter. اوكي لانه اصلا whatever is the width في proportionality، يعني اذا الويدث زادت حتزيد الفورس ب same proportion، حتزيد الاريا ب same proportion، so it will not affect the result, you will always get same depth.
هلا في the sum of fx equal whatever اللي جاي من بعدها. هلا ما بعرف اذا انا ما شفتها بالسلايدز او هي ما قاطعه، يعني ما بعرف البقايا.
هي الفورمولا تبع اللينير مومنتم. اوكي يعني انت وقتها يو ريبليس البي بفي بالقلب الايكويشن. اوكي هيطلع لك sum of forces okay equals to variation of linear momentum between الاوتسايد يعني الاوتلت والانلت. بلا لازم تكون مرقه بالسلايد، خليني افرجيكم
دكتور
قاطعه بس انه قاطعه شو اسمه
بغير
دل على دل تي لانتجرال في
دل
رو دي
على
في
دل تي، هون الدل على دل تي زيرو
اعتبرناها زيرو. اوكي
لانه ستادي
بيبقى-
ابلكيشن.
بيبقى انتجرال على الكنترول سيرفيس
اوكي
في تايمز رو.
مضبوط، هيدي الانتجرال اوكي على الكنترول
اعتبرها هون
سيرفيس.
صم.
هون هيدي بتعطيك ام دوت اوت يو اوت ماينس ام دوت ان. يعني هو لازم بالكورس ماتيريال يكون عمل لها ديفلوبمنت بعدين. ليش؟ لانه you can consider انه you have constant velocity على الانلت والاوتلت، ساعتها ما في لزوم للانتجريشن. if you have variation of velocity على الانلت والاوتلت ساعتها المفروض تخليها integral and you compute it. بس لانه constant velocities if you do the integration it will be very simple لانه you can take m dot out m dot in لبرا وعندك constant velocity. So you get m dot out times u out minus m dot in times u in.
يعني هيدا الانتجرال هي اللي حتعطيني
مش محطوطة بهيدي الفورم بالكورس.
لا
انا ما قطعت معي لا.
طب اوكي انا لكن next time I will develop it for you وبنكمل فيها تعرفوا كيف نستعملها.
can you give us هيدا sheet for the
I will.
equations?
Yes, I will. Yes, sure. I will do a summary for you for this chapter and send it to you. Okay?
And for chapter 3 as well.
I already did for chapter 3.
Okay, I didn't see it. Thank you,
Okay.
doctor.
الفور